Dear students, let us continue with the next topic of the fourth module. The next topic of the fourth module is here we have is message queue. So, what is message queue? This is also one method to do the inter-process communication. A message queue is a linked list of messages stored within the kernel and identified by message queue identifier. You must have studied in your data structure in third semester, that is the linked list. So, how the linked list used to be? In the linked list, there used to be a two field. One field is used to store the address of the next linked list, and another field is used to store the message. So similarly here message queue is also a linked list in which one part of the message queue is used to store the address of the next message queue, and another part is used to store the messages. A new queue is created or existing queue opened by message get, MSGGET. So using message get function, we can either create a new message queue or we can open the existing queue. New messages are added to the end of the queue by message send. Using the message send, we can add the new messages into the message queue, and every message has positive long integer type field or non-negative length and actual data bytes. Here three fields are there. One is long integer type field, positive long integer type field, which will identify the message queue. On non-negative length, of course length of the message should be there, and the actual data bytes, and that data should be also there. So three fields will be there, all of which are specified by message send. So using the message send, we can identify each part when the message is added to a queue. Now messages are fetched from a queue by message receive. So using message receive function, we can fetch the messages from the message queue. So remember, MSGGET, message get, is a function used to either create a new message queue or open the existing message queue. Using the message send, we can send the message in the queue, or we can add the message in the queue. Using the message send, then message receive, we can receive the messages from the queue. Now each message queue holds one address called msqid_ds. So message qid underscore ds, it is a structure, and its a different fields are struct ipc underscore perm, message underscore perm. And so next field is message q number underscore t, message underscore q num, message len underscore t, message underscore q bytes, PID underscore t, message underscore ls PID, xPID underscore t, message underscore lr PID, and time underscore t, message s time, time underscore message r time, and time underscore t, message c time. Let me discuss the different fields, what it represents. So here message q num, it represents the messages on the queue. Next, message q byte, it represents the maximum number of bytes on a queue. Message underscore lspid, it represents the PID of the last message sent, and message underscore lr PID, PID of the last message received, and ms underscore s time, it represents the last message sent time, and message underscore r time represents the last message received time, and message underscore c time represents the last change time, and all these things. So every message queue holds the one data structure called msqid underscore ds. Now here we have, let me decide, message gate. Message gate, what is its use? Message gate is used to either create a new message queue or open an existing message queue. So its a prototype is integer message get key underscore t key integer flag. On successful creation of the message queue, it will return QID, message QID, or on error it will return -1. So when a new queue is created, the following members of the message QID underscore DS structure are initialized. For example, IPC underscore PERM structure is initialized. So IPC underscore PERM, this field is initialized. Then the mode members of this structure is set to corresponding permission bits of flag, and message underscore qnum, message underscore lspid, message lrpid, message s underscore time, all these variables will be initialized to 0. Similarly, message underscore c time, here you can see that message underscore c time, message underscore r time, and message underscore s time, all are also initialized with the current time, system time, and all those things.